Hi gang, today we're going to be looking at some more equations, but instead of me just giving you the equation today, we have to work to create the equation. We're going to be translating equations with the distributive property and like terms. So similar to the equations we saw yesterday, but presented in a word problem format first. I've picked 4 equations from today's lesson that I'm going to do with you, and then you're going to try the other ones on your own with the support of a friend or a partner and my help if you need it by raising your hand. So here we go, first problem. A quarter of the sum of a number and 40 is equivalent to 17. Find the number. So a quarter, think of money. A quarter is 25 cents. 25 cents is equivalent to 1/4. So we have 1/4 the sum. So I want you thinking whenever it says something of the sum or something of the difference, we need parentheses to modify the order of operations. If you don't put parentheses, you're not using order of operations correctly because you're not going to do the sum or difference first. So we have parentheses because of the sum of the sum, and then a number and 40. So we're adding a number. I'm going to replace that with n or x, and 40 because it says sum. So plus 40 is equivalent to, is usually implies that's where you're going to put the equal sign, 17. So we have our equation. Now we have to solve for n. 2 ways I could do this. I could distribute the 1/4 first, or I could multiply both sides by 4. I'm going to multiply both sides by 4 in this case because I think that's a little bit easier. Multiply by 4, multiply by 4. I get n plus 40 equals 17 times 4. Now I know most of you are like jumping for your calculator to do that math. You don't need a calculator. Use your brain. Challenge yourself to do this math mentally. 4 times 7 is 28. Carry the 2. 4 times 1 is 4, plus 2 is 6. So it's 68. That would be the multiplication property of equality that we just used by multiplying 4 by each side. Now I'm going to get rid of the 40. If I subtract 40 on one side, I have to do it on the other. I get n equals 28. Done. So my solution is 28. Now, with this being such a short equation, if I wanted to and I had the time on a test or an exam, I would check it by plugging n back into the equation. So I have 1/4 of 28 plus 40 equals 17. So that's 1/4 of 28 plus 40 is 68 equals 17. Now, again, I know some of you guys want to just pull out your calculator and do 68 times a fourth or 68 divided by 4. You can do it mentally. 4 goes into 6 once with 2 left over. 4 goes into 28 7 times. 17 equals 17. I got it right. It works out on both sides. Therefore, we are correct in saying that the solution is n equals 28, or the number is 28. All right, so that one's a little bit straightforward. It will get a little bit more challenging than that. Jumping to number 3. Now we have a one-day pass to an amusement park costs $40 plus an additional fee for parking per person. So each person has to pay the $40 to get into the park and some price for parking that we don't know. So we're going to call that P. Then 15 people total are going to the park, and the cost is $675. Find the price per person just for parking. So we know that 15 people in total are paying $40 plus some amount for parking, and the total cost is $675. So there's our equation. 15 times 40 plus some number for parking equals $675. So now I'm going to do this by distributing first, because I don't want to divide 675 by 15 in my head. I know 15 times 4 is 60, and I'm going to add the 0. So 15 times 40 is 600. Then 15 times p would be 15p equals 675. Then we subtract 600. So 15p equals 75. Then we divide by 15, which hopefully you know is 5. So because this is a word problem, I'm going to write out my solution. The price for parking is $5 per person. which means that each person is really paying $45 to go on the trip. Okay, so those are my distributive property equations or word problems. Let's take a look at some combining like terms, where you use the substitution property of equality. All right, so number 6, we have Julie is 2 years older than 3/4 of Colleen's age. There's a 6-year difference between them. How old are they each? So we're only going to have one variable in this case, but we're finding two things. We want to find Colleen's age and we want to find Julie's age. Now, whenever we have a problem like this, you want to try to figure out, well, which person or thing should just be the one variable. And to do that, you try to figure out what is being compared to. The thing that's being compared to is going to be your variable. So in this case, Julie is being compared to Colleen. So Colleen is our standalone variable, our just X. Now we're going to write an expression for Julie around X. So we know that Julie is 2 years older than 3/4 of Colleen. So I could say it as 2 years older than 3/4 of X, or 2 more than 3/4 of X, which would be 3/4 of X plus 2. Okay, so whenever it says more than, older than, younger than, less than, you always put that plus 2 or minus 2 after the variable, not before it. All right, so now it says difference. Difference means subtraction. So we have to subtract Julie's age from Colleen's age. I'm telling you that Colleen is the oldest person. So X minus all of Julie's age, which is very tricky, you got to make sure you put that in parentheses, is equal to 6. So now we have a minus sign outside parentheses. This is something that always throws kids off. You kind of just want to drop those parentheses. But if you drop them, you're actually not going to get the right answer. It's a very common mistake. So if you have the minus outside parentheses, think of it as having -1, and you have to distribute that -1. So now I get X minus 3/4 X minus 2 equals 6. It just switches the signs of everything inside the parentheses. Now I can use the substitution property to combine like terms. So I have X and 3/4 X. Now remember that X is 1X, it's a whole, and hopefully you know what 1 minus 3/4 is. If you don't, you know that you need common denominators, so to make a whole, it would just be 4 out of 4. 4 minus 3/4 is 1/4 X. Then we can bring down the minus 2 equals 6. Then I add 2 to both sides, which gives me 1/4 X equals 8. Then I multiply by the reciprocal of 1/4, which is 4, and I get X equals 32. So we found X, which is just Colleen's age. So we know that Colleen is 32 and Julie is, let's do the math, we plug in the 32, 3/4 of 32 plus 2 would be 32 divided by 4, which is 8, times 3, which is 24, plus 2 is 26. And I know I'm correct because if I do 32 minus 26, there is a 6-year difference. Done. Okay, so again, whenever we're dealing with word problems, it's very important that you make sure you understand who is or what the solution is and how it relates back to the problem. So in word problem cases, I would always write a sentence explaining the answer or telling what the solution to the problem is. All right, one more problem. Jumping to number 8. Amanda has $350 less than twice the amount of money Paul has. The sum of their accounts is $2,650. Find how much money they each have saved. All right, so again, we're comparing here. Amanda's amount is being compared to Paul's amount. Therefore, Paul is our standalone variable. And Amanda is going to be built around X. So we know that Amanda has $350 less than twice the amount Paul has. That's like saying 350 less than twice X. It says less than, so we have to reverse it. So that's going to be 2X minus 350. Now we know the sum of their accounts is 2,650. So we are going to do x plus 2x minus 350 equals 2,650. So now in this case, we're distributing a positive. So that doesn't change anything. I can drop the parentheses. 2 plus, or x plus 2x minus 350 equals 2,650. Now I can combine like terms. X plus 2x is 3x minus 350 equals 2,650. Then I can add 350. So 3x equals 0 plus 0 is 0, 5 plus 0 is 10, carry the 1. 6 and 1 is 7 plus 3 is 10, carry the 1. $3,000, divide by 3, and x equals $1,000. So we know Paul has $1,000. And Amanda, we have to do some math. If I plug in 1,000 here, 2 times 1,000 is 2,000, minus 350 would be 2,000 or $1,650, which makes sense because 1,000 plus 1,650 equals 2,650, which is what we said the sum had to be in the equation. All right, so hopefully you understand how I came up with those equations and can try some on your own. Again, you may talk with a partner to get through those problems if somebody at your table is done, or raise your hand for some support. Make sure that before you go on to each question, you're checking in with me to make sure that your answers are correct.